Example 1. Use the given graph of fx to answer the following questions. If any of the answer does not exist, clearly explain why. So here is the graph. So we want to first find limit x goes to 2 negative f of x, mean as x approaches 2 from left. So here, as you see here, as x approaches 2 from left, the graph of f of x is approaching this point, which value is equal to 1. The second question, limit x goes to 2 plus f of x, meaning as x approaches 2 from the right, you see the graph of f of x approaching this point, so which is also equal to 1. Question number 3, limit x approaches 2. So clearly, which is equal to 1, because this is the left limit, is equal to right limit, is equal to 1. Question number 4, f of 2. As you see here, at x equal to 2, the graph has a hole here. So f of 2 is not defined, so therefore it does not exist. F of 2 is not defined. F of 2 is not defined, so if f2 does not exist. Limit x goes to negative 1 f of x. So as x approaches negative 1 from both sides, so you can see the graph of f approaching this point, which is equal to, again, the value is equal to 1. So the limit of that is equal to 1. And the next one is f of negative 1. As you see here, at negative 1, this is the point. So f of negative 1 is equal to 3. So f of negative 1 equal to 3. Last question, limit x goes to negative 3 f of x. As x approaches negative 3, you can see as x approaches negative 3 from left, the graph of f of x approaches this one, which is 4. As x approaches negative 3 from the right, the graph approaches here, which is value is negative 2. So the left limit and the right limit are not the same at that point. So therefore limit does not exist. Limit does not exist. The reason is the left limit x approaches negative 3 from left, f of x is not equal to limit x approaches negative 3 plus from right, f of x. Example 2. Use the given graph of f of x to determine the following values if possible. So we are going to use this graph to answer these questions. The first one, f of 1. So the value of the function when x equals to 1, this is right here, which is value is equal to 2. Limit x goes to 1 f of x. As x approaches 1, you can see the graph is approaching this point. Clearly, it is also equal to 2. And the second question, f of 2. The function value when x equals to 2. As you see here, this is a hole and there's a point here. So at x equals 2, the value is right this one, which is equal to 5. Limit x goes to 2 f of x. As x approaches 2, the graph approaches this point, clearly, which is equal to 3. Last one, f of 3. Here in this graph, at x equals to 3, there is a hole over here, and there is no point. So f of 3 it does not exist. And and the limit x goes to 3f of x. As you see here, as x approaches 3, the graph approaches this point both sides, and which is equal to 4. Example 3. Find the limit t goes to 4 of this function, basically using table of values, going to 4 from the left hand, going to 4 from the right, and then we need to guess the limit. So let's make the table first, and I'm going to use a calculator to do that. So in the calculator you go to y equal and enter this formula, and I'm going to enter x minus 4. Instead of t, I'm going to use x minus 4, put a parenthesis for the numerator, divided by, put a parenthesis for the denominator, will be square root of x minus 2, close that parenthesis, press enter. So you enter your formula. Now the best thing is to go to table setup, and important thing is to keep this independent variable as, that way you get an empty table when you go to table, second table. Now we have empty table, so I can find the value of this at any point we want. Say I go to 3.9, I got this number, and 3.99 this number, and 3.999 this number. So let me put this table over here now. T at 3.9, 3.99 and 3.999, I got these values for f of t: 3.9748, 3.9975, 3.9997. We have to do the same thing for the right hand side from 4.1. Start from 4.1. At 4.1 I got this one, 4.01, and then 4.001. Now let me enter those numbers. So here's the numbers what I got for ft. 4.1 I got 4.0248, 4.0025, 4.0002. Now as you see here, as x approaches 4 from the left and right, so this number is going up to 4 and this is going down to 4. So make the conjunction but the limit. So as t goes to 4, this will go to actually 4. Example 4. Use the table of values to estimate the limit. Limit as x approaches 0 of sine 3x over x. So as x approaches 0 from the left and from the right, so I create this table now. So as you see here, it goes to from left to 0, from negative 0.1, negative 0.01, and so on, and go to 0 from right, from 0.1, 0.01, and so on. So in the calculator, let's enter the formula sine 3x, close parenthesis, divided by x, press enter. So we go to table setup and keep table as, and that way you get an empty table again, and then now can find those things. And also don't forget to make the mode, go to the mode and keep this, the degree measure in radians. It is already in radian, so we good, and we go here and measure at, Let me go from the right, say 0.1, 0.01, and see at 0.1, 0.01, and then 0.001, we got the table like this. And then from the other side, negative 0.1, negative 0.01, and negative 0.001. You can see when it approaches 0 from the right and from the left, it's approaching 3 clearly. So we can write the answer here. Limit x approaches 0, sine 3x over x is approaching 3. Example 5. We have this piecewise defined function and we want to find limit x goes to negative 1 f of x and limit x goes to 1 f of x. As you see here, the negative 1 and 1 actually are the boundaries of these pieces. So when you want to find the limit x approaches to a number which is a boundary, so we have to take the left limit and the right limit, because left to this point we have to use a different formula than the right to that point. So if I want this one, I need to first find limit x approaches to negative 1 from the left f of x. So if x approaches to negative 1 from the left, so that means we need to use this piece, x below negative 1, which is 1 plus x. So 1 plus x approaches negative 1. So that means this whole thing will approach us to 0. And the right limit, limit x approaches to negative 1 plus f of x. Above negative 1, I have to use this piece, which is x squared. Negative 1 squared, which is equal to 1. So the left limit is 0, right limit is 1. So the limit therefore does not exist. So here is the work for that. And now if I want to this one, limit x goes to 1 f of x. So I need to find the left limit, limit x goes to 1 negative f of x. The below 1, we have to use this formula, which is 1 squared, which is same as 1. And above 1, limit x goes to 1 plus f of x. I have to use this formula, x greater than 1, that is above 1. So that goes to 2 minus x, which is going to 1, so total of 1. So therefore this limit is equal to 1.